Okay, so picking up on number 9, write as a single fully condensed log. So whenever you have two logs, if they have the same base and you are adding, subtracting, or dividing them, then you could make them one log. So in the case when you are dividing two logs that have the same base, they actually become one log, but the base changes. The base does not stay the same. The new base is the bottom input number. So it turns into log base 8 of 5. Okay, so this is the answer for that type of problem. Okay, so write as a single fully condensed log, express your answer without negative or fractional exponents. Okay, so the very first move, we've got two logs, they have the same base, they're being added. So I'm going to be able to make one log, but you can't do it if there are coefficients out front of the logs. So the very first move is to actually take the coefficients that are in front of the log and put them inside as exponents. So they can go inside as exponents like that. Now the directions say, so now I can put them together as one log, but I'm going to do that in a moment because the directions say express your answer without negative or fractional exponents, and we have both of those things going on here. So 4 to the 1/2, well, I'll do that later. All right, so this is log of 1 over x to the 5th plus log of the square root of 4. Now the square root of 4 is 2. And then the rule is that if you are adding two logs and they have the same base, then you could put them together by multiplying. So we're multiplying 1 over x to the 5th times 2. And 2 would be 2 over 1. So we end up with that. Okay, so that's the answer for this one here. Okay, this next one, I left this off of the test. I know when we were doing the test for you today, I left this off. But I think since then we have done similar problems. So this is just going backwards. It's like the reverse of this problem. So instead of condensing, we are expanding. So you're starting with a log, and inside of this log, we've got division. So going backwards, if we're separating this into two logs, it's going to be subtraction between them. So the very first move is natural log of the 7th root of y cubed minus the natural log of the square root of x. Okay. And so to fully expand, we need to bring any exponents that are inside of the log out front. And if you see a radical, guys, that is actually like a hidden exponent. So this is y to the 3/7, and then this is natural log of x to the 1/2. And then you could take the exponents and bring them out front as coefficients. So 3/7 natural log of y. Okay, so that's expanding. That is the opposite of condensing. All right. So we've just got 3 more. So this next one, solve. Okay, so we're solving for x. X is in the exponent, so you may be tempted to try to use a log, which is a good idea, and it actually would work. But it would be a little more complicated than if we noticed that these bases, 8 and 4, we can actually make them have the same base. We can rewrite them using a base of 2, each of them. So I've got 8 to the x minus 5 equals 4 to the 3rd. Okay. Now let me focus on these bases, 8 and 4. And off to the side, I'm going to ask myself, 8 is what to the what, and 4 is what to the what. And we want these bases to be the same. So we could express each of them, 8 and 4, with a base of 2. So 4 is 2 to the second, and 8 is 2 to the third. Okay, so let me bring the sides down. 3. Okay, so according to our side work, we're allowed to replace 8 with 2 to the third. 2 to the third. And we are allowed to replace 4 with 2 to the second. Okay. Now, at this point, we have the same base on both sides. So what we can do is set the exponents equal. And when you've got an inside and an outside exponent, you're going to be multiplying them. So since I have a base of 2 on both sides, I can drop the bases and just work with the exponents. Okay, and then I'll add 15 and then divide by 3. Okay, so x equals 7. Okay, now the next one is very similar, except this number 13, our bases are fractions. Okay. So, guys, there's more than one way, to do these things. And what I'm going to recommend, like I saw someone in class who did this using just fractions, which was great. But I think I think more people are going to understand if I do a little move at the beginning to get rid of the fractions. Okay. Alrighty, so if you end up in a situation where you've got fractions like this, you can flip the fraction. All right, so take its reciprocal. So the reciprocal of 1/9 would be 9. You could do that as long as you distribute a negative into the exponent. So see how I changed the signs? You could do that. So same thing here. I can flip the base, but then I need to negate the exponent. All right, so that might be more manageable. So you can still get the right answer if you don't do this, but I think this will, most people can understand this a little better. Okay, so what could I do for the same bases? They would be 3. So 3 to the second, 3 to the third. And at the end of this problem, guys, I'll just briefly describe what you would do if you didn't flip the fractions. Okay, so according to my side work, instead of a 9, I could write 3 to the second. And then instead of a 27, I could write 3 to the third. Okay, so now I have the same base on both sides. I have a base of 3, so I will distribute the inner exponent into the outer, like binomial exponent, and I'll just drop the bases. So this is 10x minus 18, 9x minus 42. Okay, so I'll just solve from there. So I subtract 9 from both sides, and I just get x. Add 18 to both sides. So 42 minus 10 is 32. And then 32 minus 8 is 24. So negative 24. Okay. Now, guys, we are on the last problem. So we're going to solve this and express your solution as a fully condensed log. So this fully condensed log instruction means that we can't just solve for x and then stop. If they didn't say fully condensed log, then as soon as you get x by itself, you're done. You don't have to do anything else. But the fully condensed instructions mean we need a couple moves at the end that are a little bit hard to remember, but it just means you have to practice. to, get it so it's like an automatic move for you. So I cannot do the same thing I did for 12 and 13 and get like bases because I've got a base of 9 and a base of 7, so that's not going to work. So if that happens, so we've got 9 to the x plus 2 equals 7. Okay, so if you can't get like bases, you've got to use a log. All right, so I'm going to take the exponent, x plus 2, and I'm just going to write it down, x plus 2. And then you look up here and you start like translating. What is x plus 2 in this situation? X plus 2 is the exponent, exp. Every exponent has a base. It's the exponent on base 9 to get 7. Okay, now let's translate that into log notation. So this is log base 9 of 7. Okay, so x plus 2 is the exponent on base 9 to get 7. So that's a log. And then I will subtract the 2 from both sides. Okay. Now, here, if they did not say this, fully condensed log, then you could just stop. But a fully condensed log would mean our answer is just a one-term log. Just one term, and that term is a log. Well, here we have 2 terms. This term's a log. That term is not a log. And I made this like bracket thing here long because I have to do something. Guys, what you're going to do here is you're going to multiply by the same type of log, so log base 9. But then whatever base you use, if you put that same base inside the log, that makes it equivalent to 1. So log base 9 of 9 is equivalent to 1, which is why we are allowed to just multiply by it. Because multiplying by 1 does not affect the value of something. It just is allowing us to write it in a different form. So after you do this move, what if you have a coefficient in front like this, you're just going to take it and put it inside as an exponent. Okay. All right, so let me just rewrite this. So this is log base 9 of 7 minus log base 9 of 81. And then the last move is to rewrite this as a single log, and then you're going to have 7 over 81, because if it's subtraction between, then you would divide. Okay, guys, so there is that.